So in the last video, we found the gradient of a function at various points using our graphical display. So you might have been asking yourself, why were we choosing dy dx on the calculator when we were looking to calculate the gradient of a function at a point? Well, it turns out that the gradient is the derivative. So the gradient of the tangent line, the derivative, f dash of x, dy dx, or the rate of change of y with respect to x, they're all the same thing. So if we want to calculate the gradient of the tangent line at a point, it's equivalent to calculating the derivative at the same point. So let's have a look at how to do this on the calculator. Okay, so we're just going to hit Scratchpad, go into the menu and choose option number 4, Calculus. Within the submenu, we're going to choose option number 1, Numerical Derivative at a point. And now up pops this dialog box where we have to fill in some information. So we want our variable to be x. That's how our function is defined. It's in terms of x. The value that we want, well, we want to calculate it at x equals 3. And the derivative that we want, well, we want the first derivative. So everything is in here. So we just hit enter and we get our input into Scratchpad. So we've got ddx of a blank space. So this is where we're going to fill in our function, evaluated at x equals 3. So here I just fill in the function that I want to evaluate. So it's x squared minus 2x minus 5. I hit enter and there's my answer, 4. That's the value of the derivative of this function at x equals 3. It's also the gradient of the graph of this function at x equals 3. Finally, another little nice thing to know about is we can actually call functions that we already have input into the calculator. So for example, if we go back to our graphical display, we already have f1 of x input here from the previous video. So if we come back to our numerical scratchpad, we can do the same thing again. We can say menu, option number 4, calculus, option number 1, numerical derivative. Again, we're going to have x as our variable. We're going to have our value at x equals 3, and we want it to be a first derivative. This time, instead of typing in all of the algebra, I can just define this as f1 of x. And you can see that the text has snapped from italic to bold, indicating that the calculator recognizes that this is a function in memory. Hit enter and I get the same answer. So sometimes that can be a slight shortcut if I already have my function typed in somewhere on the calculator. And this offers us another way to calculate the gradient of a function at a point.